Alrighty, good morning. I hope you're all fed and watered after your break. This is the nodeCode scenario presentation for or TypeScript for ABL developers. Or I was actually going through this and I thought, do you know what, it could actually be TypeScript or ABL for TypeScript developers. So if there's any TypeScript guys in here, this is how you can learn ABL as well. So a little bit of an introduction. I'm Julian Lyndon-Smith. For my sins, I work for a company called Build One. We're heavily into ABL and progress modernization. And as part of that, we use TypeScript, we use various other bits and pieces, and interface and hook into our back end, which is written in ABL. So for us, being able to have developers that are skilled in both ABL and TypeScript works well for us. So there's no front-end guys and back-end guys, and that's not my problem because it's everybody's problem. So everyone can read and write the code. I've been a progress developer for longer than I'd like to admit. It's kind of approaching 35, 36 years. So we've been from a journey on version 3 up to 12.8. And along the way, I've had to pick up other skills in other languages, TypeScript being one of them. So we're going to go on a little bit of a journey of discovery. And what do I want to get out of this presentation? I want to make all the ABL developers realize that they can use TypeScript, or they can learn TypeScript quite easily. It's not some mystical, magical language. As ABL developers, we have a huge amount of domain knowledge, we have a huge amount of skill in our language, which is actually quite transferable. We can make that leap or make that change to TypeScript and embrace that as part of our development. So for me, I want you guys to go, oh, I'm going to give that a try. So that's my goal for this presentation. And it's been a bit selfish, but that's what I want to do. So this is a journey in 5 parts. Sounds like Lord of the Rings. It's not as long as Lord of the Rings, don't worry. I have to say my partner, when she first saw the first part of Lord of the Rings, she didn't realize it was the first part. And after 3 hours, she went, what? Because she then realized there was another 2 4-hour films to go. This is limited to 1 hour, and it will be 1 hour. That much I can promise you. So we're going to go a quickish overview of TypeScript, its history, where it came from, and why I like it so much. We're going to have a look at the benefits and productivity gains that we can get out of using TypeScript. Then we're going to get into the really interesting parts where we're starting to draw the parallels between ABL and TypeScript, and I'll show you why it's so similar. A little bit of my TypeScript voyage, just some of the things I found out that you guys can learn from, so you don't have to find out for yourself. And when we say getting started with TypeScript, we will show you some code, we'll show you some how things run, how to install it, how to get started on your TypeScript journey. And one of the things, we're going to show that you can change an ABL class into TypeScript, and we're going to show how you can use TypeScript to run ABL, which is all very interesting. Well, I think it is anyway, and hopefully you're here, so you think it is. So, why this presentation specifically? I found that when I started using TypeScript back in, I think it was 2015, 2016, it was quite familiar for me as an ABL developer. You guys are going to have to learn JavaScript or TypeScript at some stage if you're wanting to modernize your platform or write new screens or use tools that embrace JavaScript. And TypeScript helps you with that. JavaScript by itself is quite icky, but with TypeScript, it puts an ABL type facade over the top of it. And it opens up, as we say, the new possibilities for new, cool ABL developers. You know, ABL can be cool. We can compete with the up-and-coming coders who learn all this TypeScript stuff. So yeah, as ABL developers, we have opportunities in front of us to be able to move on and extend. And of course, why not? It's a presentation, it's interesting, so. Right, I'd like to have a quick poll of OO. Who's using OO? Oh, wow. So is that sometimes when I'm forced to? No, okay, mostly? Oh, okay. Or you're a 4G, sorry, I should ABL, I should say. I'm a 4GL wizard. My OO-foo, or OO-foo, is legendary. Sorry?
My pointing method all the time. We'll stop with my pointing.
There is a reference to My Little Pony, don't worry. We'll come to that at the end, don't worry. It's there. So I've been giving various OO talks and presentations over the years, and it's amazing to see that most of you put your hands up, because normally it's one guy going, yeah, me, and everyone turns around and looks at them as if they're some sort of weirdo. But now, if we're all OO guys, I can talk OO, and you guys can understand it. Because the little point in giving a presentation based on TypeScript and OO if everyone goes, I don't know what you're talking about, I don't even know what a class is. But now we're on our way. We have a good one with this. So I probably don't need to go over this slide with you. We all know that it's type safe for properties and methods. Why I say type safe, to ABL, we are type safe, period. You define a variable as an integer, it is an integer. It can't decide to change. Some controversy here. When I started OO, I had any number of classes going any number of levels deep because it was cool, and it was sexy, and it was fun. And then I came to debug the damn thing, and it was impossible because you had to go through 10, 15, 20 classes to find this. So now, one level deep only. In my humble opinion, if your classes are nested more than one level, it's a code smell. You need to refactor, you need to fix. Unfortunately, that's not just my opinion anymore. There's a consensus that nested levels of inheritance is bad for code design because it hurts when you're trying to maintain it. We all know that classes are useful for reusability, to be able to maintain them easily and nicely. So if you do OO well, it does contribute to maintainable code. One of the classic lines is, you should always code as if the guy following you that's going to maintain your code is a psychopath and knows your address. So don't let that psychopath get you. Code well. Oops. So this is build as a nodeCode scenario, but we're talking about TypeScript. What the hell? They're very, very, very tightly linked. So TypeScript can be used in the back end, but it can also be used in the front end and back end. And on the back end, it's normally run with Node or some variant like Bun or Dino or something like that. So we'll see Node. So a history of TypeScript, #0 of 3. Do you see what I did there? Anyone? JavaScript, TypeScript are zero-based indexes. That's your first ABL, excuse me, thing you've got to be aware of. So if you're referencing array 1 in TypeScript, you're actually referring to element 2. So there are 4 slides in the TypeScript history. Excuse me. So, first introduced 2012 to enhance JavaScript's capabilities. JavaScript is not type safe. You can declare a variable, I, as char, and assign an int to it, or you can define it as an int and then assign a char to it. TypeScript stops us from doing that, so it brings us into the ABL comfort zone. Yeah, we're used to type safety, and that's the way it should work. Anders Halesberg, the chief architect behind C#, designed TypeScript. He also designed Turbo Pascal for us oldies. Who used Turbo Pascal? Yes. Who used Delphi? Yes, he wrote that as well. So this guy's pretty good at what he does. And it's something that we should remember, because if a guy does Turbo, he does Delphi, he does C# and he's done TypeScript, he's probably learned a lot of lessons along the way. Because I know I have over 20 years. If I look at my code from 20 years ago, it's, oh, hell. No, no, no. It's open source. It's free. Free to develop in, free runtime. So there's no costs involved with it. And it is targeted at large applications. It can be used for small ones, but it's also designed for scalability for big enterprise systems. So the version 1 was 2014, version 2 was 2016. Yes. As we said, it's also a superset of JavaScript, making it easier to adopt. For us as ABL developers coming from a type-safe world and classes with OO, it makes a lot more sense to use TypeScript than JavaScript, because it's very, very similar. Who used AngularJS? The first version of Angular. So then Angular 2 came along, and we had to rewrite everything. Because with Angular 2, not only did they change the framework, they also moved to TypeScript. They were using NativeScript, and then when TypeScript came along, oh, we'll have that, and they switched to that. Other frameworks like React or Vue or stuff like that also use TypeScript. So just some various other features there. It's well embedded with Visual Studio, VS Code, etc. Who wants to use VS Code? Yes. VS Code is written in TypeScript. So that's pretty cool. So the same bit of code that is used to write VS Code can run in the browser, or it can run on the desktop, and that's TypeScript. So you can target it for various different runtimes. As an ABL developer, we're very much restricted to where Progress supports the language, but you can run TypeScript on Raspberry Pis, for example. So your back-end ERP system with all the machines running and stuff like that, you can actually have a Raspberry Pi controller running some of your code talking to your back-end. So it really does expand a lot of the areas that you can start coding in. There's a huge community. We'll come on to some stats with that just now. TypeScript 3 and beyond 2018, we're now on version 5.7 of TypeScript. They released that last week. They've got quite a fast cadence of releases, and each release makes things a lot better when it comes to coding. So you have guards and stuff like that. It's got a very strong focus on developer experience. TypeScript is used to write VS Code, and therefore the VS Code language server and development tools work well in VS Code. It's a given. As we talked about, it's become a preferred choice because it reduces bugs. You can't now make mistakes with types, with bad types, which JavaScript allowed us to do. TypeScript doesn't, so it protects us just like it does the ABL guys. And it's from Microsoft, 10 years ago, for me to say, yes, I'm using a Microsoft product would have been heresy. But Microsoft are doing a damn fine job on this tool. And they've committed to it for a long time. So it's not going to go away. It's not some flash in the pan. So, now a history of ABL. Okay, there's so much of that. Now you see it's hash 1 of 10 because we're a 1-based index. Nah, we all know the history of ABL. Don't worry. It's not 10 slides of nonsense saying 1987 version 3 was released with overlay frames, and 1988 was version 4 with the editing phrase, and et cetera, et cetera, et cetera. So, how many people have used ABL for more than 5 years? Excellent. So, all you guys who have used it for more than 5 years are getting into OO. That's cool. Get into TypeScript as well, because it's just as cool. 10 years? 15. You're making me look bad now. 20. Ah, come on. There's some of you who don't even look 20 here. That's bad. So, we're moving on to part 2 now, the case for TypeScript. We're talking about enhanced developer productivity, the improved code quality, how it's seamlessly integrated with JavaScript. So all the tools for JavaScript work with TypeScript because it fits it in. If you think the Progress community is strong, wait until you see the TypeScript community. They are very strong. They are very opinionated. So much so, some of the rules that they have are vigorously enforced. We're going to have some little bit of stats. So, static typing. Something JavaScript doesn't have, but TypeScript does. I've mentioned before that you can create a variable in JavaScript and change its type halfway through. When I first discovered that, I thought it was cool. Hey, look what I can do. I can make this variable mutate not only the value, but its type. And again, when it came to debugging that was not pleasant. So as developers, we should always strive to make our code as good as possible because none of us wants to maintain code. We don't want to have to debug it and fix it. We want to write cool stuff. We want to write new features. So if you write your code as best as you can with as much quality as possible, not only is your code base going to be stronger, more reliable, you don't need to maintain it as much. And having every tool or any tool that allows you to make your code better is good. We've all seen intelligent code completion. Who uses PDSOE, I think it is now? Okay. Who used it 5 years ago? Yeah. It's rather slow, I think is the expression I would use. I think, anyone from Progress here? I'm not going to insult it then. It's a big Java-based, Windows-based thing. But we saw in that, when that first came out, it was like a revelation for us. It was a miracle because we had color syntax. We had some form of code completion. This was just magic. And just a little aside, history. Who codes in ABL what we call shouting mode, where everything's in caps because we're shouting? Okay. You two have been using Progress for must be 20 or 30 years then. No. Okay, in that case, you follow the examples in the handbook. Because when we first started coding, we only had a text editor. And when I say text editor, it was a VT220 type text editor. It was monochrome. And the only way to tell the difference between keywords and variables was to make your keywords in capitals. So you'd stand out so you could see your code. So this is where intelligent code and a decent IDE helps us as developers. And TypeScript has huge support in VS Code JetBrains, Visual Studio, and most other IDEs. Refactoring for TypeScript is amazing. If you want to move some code, you can say, highlight this code and extract this to a function, and it will do it for you. It's find all the references of this and move this to you can refactor within the IDE very, very easily. Very, very cool. And when I say better documentation, automatic documentation is the key. So when you write some TypeScript code, you annotate something to say this is function foo. There's tools that will then take that and generate the documentation for you, some technical docs or APIs, which is pretty cool. Type safety. I keep coming back to type safety. It means a huge amount because of us as ABL guys. The function signatures of TypeScript are very, very clear. They're very precise in their contract. And just like best practice in ABL is to write to an interface. So rather than having I think it's called a concrete class, I'm not particularly familiar with this OO stuff. You don't pass in a very specific class, you pass in an interface, because then you can have any number of classes that have that interface be used by this function. And it's the same with TypeScript. We talked about maintainability and how the code is much better to look at and maintain. And one of the key things that I've found with TypeScript is when you have junior programmers or people starting off reading your code, using TypeScript or well-written ABL makes them productive much, much faster. So not only as team leads or project managers, should you be wanting cleaner code for maintainability, it's also bringing people up to speed, new people. Because that's one of the most expensive parts of bringing on developers, is training them on your system, is beginning to how do they start to understand the code base. And if it's written well, if it's written in components, in modular parts, people pick up on that a lot easier. And enhanced testing. Again, TypeScript has a huge range of testing tools. ABL, we've got ABL unit. Is that the Progress one now, ABL unit? There was about 3 or 4 at the time, open source projects. I think they merged into one. So again, TypeScript has all sorts of tools for front-end testing, for back-end testing, Jest, and this is where interfaces come in because you can inject mock data into your classes rather than a database connector, for example. Whoa, what happened there? Sorry. Right. Right. It's behaving. We talked about the vibrant community. There's a huge amount of people who are willing to help. And one of the benefits of the generative AI that's coming through now is that you can ask ChatGPT or Gemini or any of the other AI engines, how do I do this in TypeScript, or write me some code? And because there's 1 million open source repositories in TypeScript in GitHub that are open source projects, ChatGPT's learned from this. So you can actually write some really pretty good code by asking ChatGPT to do it for you. So you can really look cool by your team manager by saying, yeah, I'll learn TypeScript and by tomorrow write some code that does something fancy because you've asked ChatGPT. Because of the nature of the community and the number of open source projects, the AI can get all that code for you. We already mentioned briefly the regular updates. Microsoft do release quite often. It has a wide adoption. There's a large number of enterprise organizations using this now. And for educational resources, there's a large number of tutorials, courses, and you just need to search the web and you can just page after page of these. Some of them free, some of them open source, some of them paid for, and stuff like that. It's the most popular programming language, or 5th most popular programming language on Stack Overflow. 21% to 34% in 2023. It has 95,000 stars on GitHub. 95,000. People are happy when they reach 5 or 6 or 7. This is 95,000. It is downloaded 90 million times a week. That's staggering. Now, obviously, that's not 90 million individual people, one person. So we're getting 90 million developers every week, otherwise we'd all be in trouble. But it just shows the traffic on that website for NPM. So let's get to some cool parts. We've done the boring bits. Let's get to the exciting parts. We're going to draw parallels between OpenEdge, ABL, and TypeScript. We're going to look at the naming conventions, the file locations, how you compile and build, and then we're actually going to then dive deeper into the classes. We all know that ABL forces the source file to be the name of the class. You can't call a class foo and have it in bar.cls. It has to be in foo.cls. Your TypeScript class name can be anything, and it doesn't matter. Naming convention is Pascal case. Oh, do you know, I never get camel case and Pascal case the right way around. I've always got to look it up. So I hope that's right. Pascal case starting with a capital. So that's a naming convention. It doesn't have to be that way. And one of the bigger things is that you can have multiple classes per source file. Again, with ABL, it's one class, one source file. In TypeScript, you can have a number of those. So where is the code? For us, ABL guys, it's defined in a single CLS, which compiles to a .r. Folder structure is the namespace, for want of a better word. So we build one automation hub workflow CLS creates the class build one dot automation hub dot workflow. And we can use using to have shortcuts. So you can now say, you know, it's now just a new workflow because we're using the automation hub dot star. I used to like that. I don't anymore, because the using statement, if you're looking in your code, you don't necessarily know where that's come from, because you might have inserted another using statement after that, referring to a workflow class as well, and suddenly your code breaks. With code completion, with all the stuff that we've got now, I tend to always use the full class name, so that I'm not at vagaries with ProPath, with extra using statements breaking something, or something like that. It's just a personal thing. Just what I've learned over the last 20 years of writing OO code, I find using is messy. Just my personal opinion on that. So with TypeScript, one or more classes in a single file, you export the classes so they can be consumed by something else. So if you just define a class in a source file, you can only use it in that source file. You have to mark it as exportable to be able to be imported somewhere else. You can create what's called barrel files. I'll show you what that is. So you can have 4 or 5 TypeScript classes and 4 or 5 files, and then have one file that imports and exports everything. So if you import from that one file, you have all your classes. So Here's a bit of TypeScript code. We've got a class greeter and a class waiter, and this is in the PUG challenge people .ts. So a .ts is a TypeScript file, or an MTS is a module, but we'll get to that. So TS is for TypeScript. We've got two classes in that bit of code. We're exporting both classes, so both those classes can now be used. In the ABL, we would just have class greeter in greeter.cls, and we'd have class waiter in waiter.cls. And we don't need to export or anything, we just declare it, unless, of course, it's private or not usable. So we've now got another file called PUG Challenge Kitchen, which has the starter class. And for the dinner class, we're importing greeter and waiter from PUG Challenge people, and we're importing the starter from PUG Challenge Kitchen, and then we're just instantiating some new classes. So you can see that's, especially those lines 4, 5, and 6, if you had var greeter equals new greeter, that's your ABL code. So you can see it's pretty similar in some ways. We're going to take this a little step further now and create a barrel file. So we create a file called pugchallenge.ts, and we're exporting everything from PUG Challenge Kitchen, and we're exporting everything from PUG Challenge people. And then in my code, I can now import everything from PUG Challenge. So I don't have two sets of imports now. I have a barrel file that exports everything to do with PUG Challenge. So I've got my three classes there. Compiling code. We all know it compiles to .r, which is the standard. I hope you all bundle your .rs into PL files when you distribute. Yes? No? No? Oof. It's much easier. And I'll tell you why it's much easier, because it's one file to put under asset maintenance, so you can then put the PL in your asset repository and get that PL. We actually use the PL and publish it as an NPM package, so that our clients can do an NPM install, and it installs the progress procedure library, which is pretty cool. And if you had multiple .rs, it's a bit more tricky with that. But we do the same with the web UI, the front end of our code. We do, so the web UI and the back end are both published as NPM packages, which then means that when someone installs our packages in a node environment, they can just NPM install and have progress code. Pretty cool. TypeScript you compile with TSC, TypeScript compiler, or Babel, or any number of transpilers. And what it does is it takes the TypeScript code and converts it into JavaScript. So you end up with JavaScript file. And when you look at the JavaScript compared to the TypeScript, you go, holy moly, because it's a mess. It's horrible. I know it's optimized. I know it's meant to be optimal. But that's the sort of code you'd have to write in JavaScript if you weren't using TypeScript. You can then bundle all into a single JS, so one file contains all the JavaScript. And that's not like a procedure library. This is basically one JS file with everything put in as functions. It's huge. It's messy. But the compilers and builders also enable what's called tree shaking. So for us as ABL developers, we might have, let's say we got 1,000 classes in a folder. The system compiles those 1,000 classes. We have 1,000 .rs. We put those 1,000 .rs into a PL, and we ship it. What if only 3 of those .rs are actually used in the application? We still ship the whole damn thing, because we don't have tree shaking. With TypeScript and JavaScript, the compilers and the builders analyze the source code and determine if a function is used or not. And if it isn't used, it's thrown away, which is pretty cool. So you end up with only the functions, the methods that you're actually using in your application. Now, we have some issues with progress in trying to determine that, because of course we can say run value, which is functionally very clever, but again, when it comes to debugging and maintaining it, it's a nightmare, because that run value, that data could come from anywhere, so you have no idea what it's going to run, which is quite messy. So try avoid that if you can. So let's get on to the cool bits. We're going to go through the various class. Oh, great. I didn't start my timer. We're going to go into the various classes and go through like for like with TypeScript, progress, and everything. So we're going to have a look at constructors, destructors, the properties, the methods that we have, inheritance, abstracts, and statics. So even the pretty abstract stuff in OO, there is an equivalent in TypeScript. So, who uses multiple constructors? You can't in TypeScript. Well, we'll come to possibly. But TypeScript has one constructor. And that's just the way it is. So for us as ABL guys, if we have a constructor that takes an integer, or we have a constructor that takes an integer and a character, or integer character, or integer character, you can see where this leads. It's when do you stop? TypeScript only has one. So you can do some form of overloading. It's not overloading, but there are ways of constructing a new class with different constructor methods using either union parameters or factory methods. One of the cool things with TypeScript is you can say option is either a Boolean or a string. So you can narrow the type safety down to say, I'm having an input, it can either be a Boolean or it can be a string, but it can't be both. It can't be both, and you can't put a date, you can't put an integer. So you still have the type safety, and then within the TypeScript, you can do a type of. You can check to see what type the option is, and do code that way. So you can have two constructors, one's taking the Boolean, one's taking the character, but it's one constructor. Or you can have a static method. So we have a base constructor, but we also have a static from string and from Boolean, where you pass in the option as a string or the option as a Boolean, and we set the appropriate properties, and then return the new class. So we're creating a new greeter class, we're setting the values, and then we're returning that class. So that's, I believe, is a factory method. So you're using a factory to create the class, and you're passing it in two different ways. So that's how you can get around multiple constructors. Destructors. There isn't one. I'm going to say there isn't one, because we're going to move on. Because even the guys who show that a destructor is possible say, don't do this. So they've gone to the trouble of making a type of destructor, but then they've gone, we shouldn't be using this. So we're not going to use that. So there's no destructors. There is no finally either. Now, finally is a really, really cool feature in OpenEdge. And we use finally for what? Anyone care to throw out why do you use a finally? Cleaning up your objects. Wouldn't it be great if Progress cleaned up our objects for us? TypeScript does that. Any other reason? Or finally, for those who don't use it, just basically says, when this thing is about to end, do this. It can be in a for each, can be, in any repeating block. So a destructor is effectively a finally for a class, for want of a better word. But there ain't any in a TypeScript. So there's no destructors, there's no finalies. So there's something you're going to have to consider. Methods. Similar to the ABL. Marion, you should be happy now. If you were paying attention, you'd see. Our methods are very similar to ABL. Within a class, we have a method, at this time called My Little Pony, which returns Pinkie Pie. Again, there is no overloading, so you can't have a method like we do in the ABL with different parameters. And one of the, when I always get frustrated with this, I always think, this guy wrote Turbo Pascal. This guy wrote Delphi. This guy wrote C#. This guy wrote TypeScript, and he deliberately didn't include this. He did not include function overloads. I don't think I'm as clever as this guy, as Anders is. So I tend to try and rein in my expectations and work a different way. Just call it a different method. Give it a different name. So then in your code, it's understandable what you're doing. Properties. They are simply a variable on the class. So we have to define property X as char, get, set, etc. For TypeScript, it's a simple variable declaration. Private option 1 or private option 2, whatever the things are. You have getters and setters as well. So if you're wanting to perform a function before you set a property, you can do that, or setting it or getting it. So you can see here we're doing we've got a private variable, a private property, sorry. We're getting full name, and we're setting full name. Now, that's a contrived, because normally you'd have first name, last name, you'd append the two together and return them. But it's just showing you that we have a get and a set, just like we do in ABL. They can be public, they can be private, they can be static, they can be abstract. Sound familiar? We've all used those. That's in the TypeScript as well. Inheritance. I'll say again, change my mind. One level deep, please, people. I remain to be convinced, but I'm sticking to this. And that quote there came from ChatGPT, so it must be true. It might be one of the hallucinations John was talking about, but I'm taking solace in this, I'm believing this. So as a general guideline, more than 2 or 3 levels is often seen as a red flag or code smell. So just bear that in mind whether you're coding in ABL or TypeScript. But the point is, TypeScript has inheritance. It's not called inherit, it's called extends. JavaScript is not an OO language. It doesn't have any OO constructs. TypeScript is a OO facade over the top of JavaScript, so you don't actually inherit, you extend. And what that means is you take the code in. Yes. Yes, you can put your own in and then call super. But, yes.
In TypeScript, this might be the idea why they are using extend instead of inherit, because you can't override.
Yeah. Because there is no OO in JavaScript. There's no such thing, so you cannot inherit. That's why you extend. So here's an inheritance example. We have class animal with a name and a string. It has a method called moveDistance. Snake extends animal, and it can move 5 at a time. My Little Pony extends animal and can move 45 at a time because it's magic. But you can see now we've got 3 classes in one file, and they're extending or inheriting each other. You can see it extends here. So snake extends animal. Now looking at that code, it's neat, it's compact, it does everything that ABL inheritance does, or what ABL class methods do. So you can see why it is quite similar. So again, abstracts, similar to ABL. Abstract classes cannot be instantiated, they need to be inherited. All properties and methods available to the subclass. So here's an example of an abstract in TypeScript. We got the getArea. We got a describe method, which just does a log. That's terrible code, by the way. Do not use that as an example. It should return a value, and then you decide what to do with that value, rather than just logging it like that. But with that class there, we can now extend the shape and implement the method. So we have super. Sound familiar? Again, that's in the ABL. It's almost as if Anders read the ABL when he's constructing TypeScript. It's very, very similar. And getArea number. Now, you don't necessarily, so what this function is doing is saying getArea is returning a number, which is this times height. What TypeScript does is you don't necessarily need to specify that colon number, because the return value would determine the type of the method. So if you wanted some shortcuts, you could just say getArea, and it would return a number because it's of that return statement. Again, I find it's better to document my intention when writing a method. I'm always going to intend that this is returning a strict type, because someone reading it can then just go, oh, that's a number. In the IDE, you have all this help. So you could hover over that method and it says, oh, returns number. So again, a lot of the modern tools and technology help us in this regard. I'm a little bit old-fashioned. I still like to document what this thing is doing. And again, with methods and properties, this is not ABL, this is not TypeScript, but name them properly. Don't say I in I1 for width and height. Call it width and height. It's code completion. You don't need to worry about having to type out 12 characters for a property name. It just completes for you. And you can make the code much more readable by having meaningful names. So here we have the circle. Was previously we had the rectangle, was it? Yes. So they're both extending shape. But this one's getArea is pi times radius squared. Pi r squared, yes. Just had to think about that for a second. And here's the code to instantiate those. So we're having a new rectangle, we're describing it, we're having a new circle, we're describing it. So very simple, very easy, it's very clear for an ABL developer what this is doing. So you're reading TypeScript code with your ABL 00 minds and hopefully understanding it without maybe knowing TypeScript, but you can understand the language because the constructs are very, very similar. Let's skip over something. Oh, stop that. Statics, again, like ABL. It's getting familiar, this, isn't it? Like ABL. Declare a static property or a static method, and you can call them. So we saw that in the factory methods to return a new class. But in this case, we're just returning Pinkie Pie. So we have a new static method. So console log greeter My Little Pony returns Pinkie Pie, but this generates an error. Why? Anyone hazard a guess? The constructor is private. It's just like ABL. You can define a private constructor, which means you can't instantiate that class without going through a factory method, which absolutely determines what you need to do to set up that class. It's a pretty neat trick. So you can only use static methods, the static method in this class. You can't create a new class with it. So in this, we're talking about here about you can simulate a static class by creating a private constructor. With ABL, when we create or instantiate a static method or property or class, that static is loaded into the runtime memory and cannot be got rid of. Once it's loaded, it's loaded. So if you're writing a static class and you're trying to debug something, you've got to start the session again. You've got to stop it down, start the sessions. So be careful about using those. You should use something similar to this, where you have one static method that returns a new class of that static. So that if you're wanting to, you can delete that object, and then the next time it'll just create a new one for you. Class events. There aren't any. That's simple. Let's move on. There is PubSub in JavaScript called emit, so you can emit events and listen to them, but they're not class-based events. So as I say here, it's similar to PubSub in non-OO classes. We've all used PubSub, publish here, subscribe anywhere. It's pretty cool. And the TypeScript emit does the same thing. I mentioned earlier interfaces and how it's a good idea to use them. TypeScript has interfaces. Again, similar to the ABL. And I hope you're all using interfaces to do that, because you can specify a standard contract then for each class, which then behave in the way that they interact with the system. So you can pass in different classes. If they have the same interface, you can use that within the method that you're passing this into. For TypeScript, the naming convention is it begins with an I. Again, us developers, a little bit of history, ABL history. The reason why we generally use short variable names and short field names was our code contained all of that data, and every reference to the variable repeated that. So if you had a 12-character variable name, if you referred to it 20 times in the code, it was embedded in the R code 20 times. And back in the day, our R code was 63K in size. That was the maximum level you could have. So we went on the I, and X, and H, because it saved bytes. I would now name them differently. I would find different ways of doing it, because maintaining that code is very, very difficult. A true story, one job I worked at, all of the tables were 2 characters long, and the field names are 4 characters long. And that was the boss's coding convention. Why? Because it lined up nicely in the editor. No other reason. Just insane. So here's the interface example. We have a clock interface. The clock implements the clock interface with the current date, current time and set time, properties and methods. Nothing fantastic there. That's what ABL does. So we come on to my little journey with TypeScript. So lessons learned moving to TypeScript for me. Implicit typing. Let number equal, my number equals 42, let my string equals hello world. So no types. Just declaring a variable, assigning a value. Dynamic typing. My variable is 42, I'm now assigning it a string. You can see why JavaScript was an experimental language that accidentally made it into, what was it, the browser? Netscape Navigator. The guy probably didn't really intend this. It was an experiment, and he had to fire it in, I believe he had a month to write JavaScript and put it in. So there are some really bad mistakes along the way. And it was called JavaScript by Netscape because Java was cool. So we're going to call it JavaScript. It has nothing to do with Java, but everyone thinks it's cool. Weak typing. Let result equals 5 quotes plus 1. Gives you 51 string. It's like, what? For us ABL guys, this is just stupid stuff. This is just insane. And these are some of the problems, because I started my JavaScript journey using JavaScript. So I was writing code without classes, which I was used to, and I just kept falling across all this sort of stuff all the time because I'm so used to the ABL protecting me and looking after me. And JavaScript was like, whoa, no, I'm going to let you shoot yourself in the foot with a 12 bore and 6 cartridges, and then the other foot. Oops, some gotchas. So x is 1, so we think x is a number. Y is 2, we think that's a string. If x equals y, do this, else do that. Now I'm going to say, what do you think this is all going to do? And you're all going to say, well, it's not going to do this, is it? Because you wouldn't put this quote up. But yes, it does log do this. It's like, what? How? Why? Well, that. Equals in JavaScript is not equals. It's an assignment. So we're assigning x equals y, and the value is true because it succeeded. So true, yes, I'm going to console do this. Even if x is a number and y is a string, x equals y, you look at that code, and you can sit there debugging this code for hours as an ABL developer until you go, oh. And this is where TypeScript helps, because TypeScript, that would raise a syntax error. JavaScript won't. 5, excellent. Global variables. Is anybody going to admit to using global shared variables? Stop it. Global shared variable, oh dear. We have a perfect candidate for open edge modernization here. Global variables should be on the banned keyword list. Yes. Out if you're going to cause this sort of trouble. And JavaScript allows you to do the same. You can just declare a variable name equal a value without declaring the damn variable. Again, TypeScript wouldn't let you do that. Because, of course, what I did is further down, I used global var with a little v and set it to some other value. And I couldn't understand why global var was still I am global, because I'd changed it. Well, no, I hadn't. I'd done something else. We have an array of 1, 2, and 3. Array 2 is array. We're pushing array 2, and we've modified both arrays. Because it's by reference. It's not a copy like ABL. And undefined, not referenced error, because we're trying to reference it before. That's a, when it says it's undefined, you'll say it's undefined. But we're declaring the variable past the statement, but it still compiles. Yeah. And we have the unknown value in ABL, and this is NaN, so not a number. So you try and convert a string that's got hello world, and you try and convert it into a number, you'll get NaN, not a number. But not a number is not a number. It's quite funky. And comparing two arrays is false, because they're two different references. So they're not the same array. They're not the same values. So, I know disclaimers. It was pointed out to me yesterday that disclaimer should be at the top of a slide because it's a disclaimer. Well, I wanted to go through all the TypeScript stuff first and say, yeah, you're not going to be a TS wizard after this, but you will understand, well, hopefully you'll understand that you can use TypeScript as an ABL developer. And code formatting in slides is not optimal, I think would be an expression I would use. So there are two types of people. Programmers will know. Who does the first set? Oh, good man. Who does the second? Yeah. Now that is generally personal preference, corporate standards or whatever. But it's very hard to enforce that in editors. PDSOE does a reasonable job sometimes, but trying to enforce it is difficult. With JavaScript, these two are the same, although they were written differently. It's because in the VS Code editor, there's linters. So you can say, I want my code to look like Airbnb's code. And you can literally import the Airbnb linter, and it will reformat the code for you. So the code is always going to be consistent. No matter what programmer you are, or what developer you are, when you say that code is going to get converted. You're just going to have to live with that, because that's what VS Code does for us. Oops. Yes. So here's our ABL code, class greeter, public property, with a constructor, with a method. We're all familiar with that, yeah? There's TypeScript equivalent. So class greeter, public, with a constructor as an input. We're assigning the greeting property, assigning this object. So in TypeScript, it's this, not this object. And then we've got a method to do that. I'll come to installing Node when I say the wrong way and the right way. But for Node, for installing this stuff, there's one way and one way only. Use Docker. Do not install Node on your development laptop or anything like that. Use Docker to do it, because you can fire up any number of Node versions, you can remove the container, you can remove the image, and your machine hasn't been affected or infected by anything. And we do the same at Build 1. We do not install Progress. We use containers. So we can have any number of versions of Progress running in the same thing without actually installing it. We just pull our Docker images. So that's the way, right way and the wrong way. Hopefully, you'll be able to see this. It's just a very quick sample of, where's my mouse? So what we're going to do here, we're going to load up the demo class. You can see we've got property foo, class demo, with the constructor, the greet method returning the foo property. And our test program, using demo.star, which I told us not to do, we're going to run the program. So from VS Code, we're going to run the ABL code, which compiles it, outputs the terminal. Hello, PUG 2024. So now what we're going to do is we're going to copy the progress class. We're going to paste it into demo.ts, because that's our TypeScript code. And we're now going to convert it in line to a TypeScript. So TypeScript doesn't have end class or colon. It's an open squiggly and a closed squiggly. So we're going to change that. You don't define a property. You just say foo string, or public foo string, as we're going to call it here. You don't necessarily need to use public, because by default it is public. So we have a public foo string. Our constructor, again, we're going to have a string within there, open and close curlies instead of the colon and end. We're going to assign this dot foo as the message. Dot becomes a semicolon. Get rid of method char. We're just going to say it's greet. We're going to return this dot foo. Convert the squigglies, so the colon and the end. And we have a TypeScript class. Press save, and it's now formatted. So now we're going to, in the same file, we're going to copy the ABL code. This is non-OO. We're just going to copy the ABL code in here. We're going to change that into TypeScript by saying, const test equals new demo. I don't technically need to do that, and my spelling isn't very good. So we put a semicolon in there, and we just replace message with console.log and put greet inside that container. We now need to compile the TypeScript, which we're going to do. I'm just going to copy the path. So TSC, demo.ts, you'll see up here, we're going to get a demo.js file now, and we're going to run it. And it's hello pug24. So that was just a real-time conversion of the class, which is pretty cool. If you compare them side by side, you can see they're very, very similar. I'm just going to move on because we've got one more slide to give. So we're going to call the ABL now from TypeScript. So we're going to go the other way. We're going to create, or we have a TypeScript class that's going to run this .p for each SportsDB formatted. We all know that code. And within our code here, so we create a class called utilsexec, and what that's going to do is allow you to do an OS command effectively. And we're just going to exec that and return the output. So you can see here we're connecting to the database on the local port minus. And I have to remind you, this is all running in the browser. So we're running this development in browser because we're using Docker. We've got database servers, PAS-OE servers, all this sort of stuff. So now when we compile this code and then run this code, we're going to get all the data back from the customer. Bosh, goes the other way as well. So using TypeScript to call ABL and vice versa, you can see there's a lot of stuff there. I have slightly overrun, I'm afraid. So I'm just going to do a quick wrap up. We've been on our journey of discovery. We're looking at how the history of TypeScript, the benefits of TypeScript. We've drawn some of the parallels. My TypeScript avoids some of the little gotchas on why you should use TypeScript. And we're getting started with TypeScript there. I'm around for the next couple of days if there are any questions that you want afterwards. But does anyone have any questions right now? Well, I hope that I've excited you, that I've convinced you to investigate, to look at TypeScript. Go on that journey. It's well worth it. And add TypeScript to your ABL toolbox, because you can make use of it. And it's really, really cool technology. All right, well, thank you for attending.